Hello. In the next couple of videos, I'm going to go through how to organize your GUI data for Eagle. So in this video, what I thought I'd do is I'll go through the two mandatory files that are required for any analysis in Eagle, which are the snip data and the phenotypic data files. And then in subsequent videos, talk about the map data and what goes into the Z matrix data file. So snip data. Couple of choices available to you on how you might like to organize your data. You might like to organize your data as a VCF file. And if you do, we're assuming you have version 4. It needs to be tab separated, which is what all VCF files are. We're assuming that you have actually genotype data contained in this file. But one of the nice things about having a VCF file is not only does it contain the SNP genotypes, but it actually has map information in there. So if you use the VCF file type in Eagle, then we will extract the map from that data file. So there's no need to supply a separate map file. And then just that last statement, for those of you who are sitting in R land, and it's just really example just how simple it is to read in VCF data into Eagle. We use the read marker function. You just need to specify the name of the file, which in this example, I'm just calling it foo.vcf. And you need to tell that function the type of data that you have, in this case, VCF. Another way of organizing your SNP data is to have it as a plain text file. So plain text files, the rows of the individuals and the columns of the SNPs, it needs to be a space separated file, and you're not allowed to have any column headings. So don't stick SNP names as the column headings in this file, because that will cause Eagle some grief. We're assuming that you have genotypic data, so you have genotype calls. But what I've done there on the left-hand side is, at least at face value, it looks like you've got three very different files, or three different representations of the SNP data. But if you look more closely, they're actually the same data, or they're interpreted in the same way in Eagle. In that first data file, that first table, I've coded the SNP genotypes as 0, 1, and 2, where the missing is -9. In that second table, I have more allelic information where I've got 1/1, 1-2, and 2-2 as the genotypes where NA is missing. And then in the third case, something that would not be, most people wouldn't do that, but Tom, Dick, and Harry is the genotypes and missing as the missing. So they're all represented the same ways, but you do need to tell Eagle what the coding is. So what I've done is given you an example of what the R function would look like for plain text SNP data. So again, you need to specify obviously the file name. You need to tell Eagle what type of SNP data you have, in this case text. And in this case, you also need to tell Eagle what the mapping is. So you need to map your genotype calls to what Eagle needs to know. So in the case of that middle table, the the 1/1 is representative of AA, the 1/2 is representative of the genotype AB, and the 2/2 is representative of the SNP genotype BB. So the only thing with this is you can't change your coding halfway through. You need to have that same coding all the way through. But other than that, it's pretty flexible. You can have whatever you want. And then the third way of representing SNP data is as a P-Link human readable PED file. So there is information sitting on the P-Link website of what the structure needs to be, but just a couple of things to note. It's a space separated file. You can't have any column headings, and we're looking at allelic data. And because we are looking at allelic data, it means that each SNP in the data file has 2 columns of information for the 2 alleles. So the total number of columns that you have in this file should be 6 plus 2 by 11. So the first six columns are ignored. They're just dummy columns, at least to Eagle, they're dummy columns. The data starts from the 7th column. You are allowed to have missing data, and they're coded as zeros or dashes, which is standard P-Link. And then that last bullet point there is again an example of how you'd read in a file called foo.ped into Eagle. And all you need to do is just specify what type of file you have, which in this case is Plink. The second mandatory file that you need to have for Eagle contains the phenotypic data. In this file, the rows correspond to individuals, the columns correspond to whatever trait information that you have. We do need column headings in this case, and you are allowed to have missing values. You'll need to tell Eagle what the missing values are, but you're allowed to have missing values. The file's allowed to be space, comma, or tab separators. And if you're sitting in the plan space, this is going to make sense to you. If you're humans or animals, then you don't need to worry about this. But you are allowed to have multiple rows that correspond to the same sample. The file can contain multiple traits, so you don't need to have a separate phenotypic data file for each trait that you want to analyze in Eagle. You can have it all sitting in a single file, and Eagle works best with continuous or quantitative traits, and that's because Eagle's based upon linear mixed models. And then just that last bullet point is an example of how you'd read phenotypic data into Eagle if you're doing it through RLAN. So you're doing it through just traditional R function calls. You use the read pheno function. You specify the name of the file, which in this example is called foo.dat. You need to specify what the missing code is, which in this case is NA. And also, if you have a space separated file, you don't need to worry about this, the sep option, because by default, Eagle assumes you have space separated data. But if you do have comma or tab separator, you do need to use this sep option. And in this particular example, I'm just giving you um, an illustration of if you're using tab separated data, what it would look like, the function call. So in the next video, what I'll do is I'll go through what the structure is for the map data file if you need it.